Okay, we are going to show you what we have now is protein preparation. How to prepare a protein for molecular docking. Remember that I told you that this protein, like this milk we used, we downloaded a protein that has a ligand complex with a ligand, milk. We downloaded it from PDB complex with a ligand. A ligand. I also remember that this protein complex with ligand, it was done in a wet lab. It's a wet lab experiment that was now captured uses X-ray crystallographic techniques. When you go to PDB, you see that some of the things deposited there are captured with X-ray crystallographic techniques, electron microscopy. So these things were done in wet lab experiment and they captured and deposited, you know, and then deposited on after several processes, deposited on PDB for you and I to download and use. So you to make it easier for you, when you download these proteins complex with this ligand, you take them to PDB to Pymol, and then the video for the preparation for Pymol editing, you also get the link. So this protein, what we did that day was to save two of these proteins. We saved one with that ligand it complex with, and then we save the other without the ligand. These are to make things easier for you. And I told you that for us to do molecular docking, we need that one without the ligand. You can also use the other one, also the one with ligand to do molecular docking. But to avoid certain level of confusion, we used the one without ligand to do docking. So I'm going to show you how to prepare without the one without ligand, and also explain to you why we need the one with ligand. The one with ligand, we needed it to be able to get the dimension where the ligand is located on the protein, since we are using the one without ligand to do our docking. So to prepare protein molecular docking, I've already downloaded these proteins and edited them in Pymol, which you get the link for. So now I'm showing you how to prepare this protein for molecular docking. In preparation of ligand, when you look at this screen here, you see ligand. We are clicking on ligand. To prepare proteins, we need to click on File and look and click Read Molecule. It takes us to go and it brings us a dialog box for us to choose where we saved this protein we now want to prepare. So this protein, I saved it on the desktop and I used the folder called Dan. So if I go to folder called Dan, there should be a folder here called Dan. I'm going to see this protein. You can see there is two of them here in PDB. We have one, we have a without ligand. You can see without ligand. See the file format is PDB. Also have with ligand. So I'm going to show you how to prepare the with ligand. So I click on it and open it. Allow it to load. So it's going to load here. So this is the protein. These are protein uh, with ligand. It is the same process you use to preparing both of them. But I'm going to do the one with ligand first and then show you. Okay, let me do the one without ligand. Let me remove this one with ligand and do with the one without ligand. It will give you a better knowledge. So when I click on File, Read Molecule here, and then I go and select protein without ligand in PDB. Remember, it was 6GVX we downloaded. So I click on it and then open it. And then the next thing I will do now, I will allow you to load. So this is the protein here. I click on edit, go to hydrogen, add hydrogen, select polar only. I will do a next video, where if you want me to detail, there's some reason why we add hydrogen here. PDB molecules, PDB file deposited, structures deposited on PDB are known to have polar hydrogens. So we are adding polar hydrogen and then click OK. Just select polar only Say okay. You will see what will happen to the box, to the protein, that some white parts just appeared on the protein, that the polar hydrogen we added. So after adding the polar hydrogen, we go to grid, then macromolecule, choose. A dialog box will come out here. In that side of the dialog box, you are going to see the name of your protein, the name you saved your protein with, cis-GVX without ligand. You click on it, it will become blue. Then you say select molecule. You select the molecule, and then after selecting the molecule, a dialog box will come out telling you one or two things about the molecule. You click OK. And then once you click OK, it now brings you an option immediately to save the protein as PDB. When you look now as option, save as type is PDB. Is PDBQT inside. Save as type PDBQT. The file name is still your protein. You can still change it to anything, but the most important thing is always remember where you save these things, whether you change the name or not. Always remember where I save these things. So since I'm using a folder called Dan for this. So I would have to go and save it inside this Dan, or any other place I can save it. Just save it anywhere. You can always remember. You can retrieve it easily. Say save. So I've prepared this protein for docking. Remember, this one has no ligand. So I'm also going to do the same thing to the one that has a ligand. Remember what I said? This process might be tedious, but it makes it easier for you to understand what you are doing. So we go and they open the one with ligand, read molecule. We open, can see cis-GVX with ligand PDB. I open it. I will bring it here. It brings here. So I do the same thing I did for the other one. The one that ligand edit, hydrogen add, polar only, okay. And then I also do grid, macromolecule, choose. I will see inside the dialog box, I will see the name of the protein, the name I saved the protein with, cis-GVX with ligand. I click on it, it becomes blue. Then I say select molecule. The background becomes blue. Now I say select molecule. Immediately it brings out a box telling me one or two things about the protein, and then I click OK. After that, it tells me to save the protein as PDBQT. I'll do that. Just the same thing I did with the other one. But this time around, after this stage, we need something else. We need to go further. The further we are going now is to prepare the protein as PDB, is to prepare we have the protein now in PDBQT. What we need to do now is to make a grid box around the ligand on this protein. Looking on this protein, we cannot find the ligand is there, but because of the way the structure is appearing, everything is appearing, we need to make it easier for us to see the ligand. You will see why we need to make it easier to see the ligand. We now have the protein in PDBQT. We need to do something further. Go back to grid and say grid box. So once you see, when I click the grid box, this dialog box appeared, and then there is a box now that has sides in colors. That box has a green, red. You can see the box, green, red, and blue side. When you look at this dialog box here, it has red, green, blue up, and then down also it has red, green, blue. We need to make sure that our ligand, which is attached to this protein, we need to put it inside this box. And to be able to make it more efficient and easier for us, we need to find a way to identify the ligand on this protein. The easiest way to do that is to hide the protein, leaving the ligand only. So how to hide the protein is this. When you look at this side, you will see this box, this round, I say a square box here, and then we have round, 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 and then triangular, uh, triangular, uh, stuff. You see this one, the second red box, the second box there, the second the first circle there has a red color. If I click on it, everything disappears. In fact, it didn't disappear, but everything gets hidden. So when you look at the extreme here, where I have the name of my protein, CGV with ligand. So if I click, there's an arrow here. If I click it, it will show me the component of that protein, which is chain A. If I click that arrow in front of A now, it will show me the components of the protein. The component of the protein, these are all the amino acids. But in all these component of the protein, we need to identify the ligand, because that ligand, since it's attached to the protein, is also a component of the protein. So we need to look here and identify which one is our ligand. And this is it. You see the last one. How do I know it's the last one? When you watch the link on the editing of protein using Pymol, you will see that or you can find it easily when you view your protein sequence on Pymol. You find the ligand attached to the protein with a code. How do I know the code of the ligand? When you go to PDB, which I will show you in another link, you will see that for ligands complex with a protein, there is a full name, there's a chemical name for the ligand, and there's a code name. Because I already know that the code name for this ligand is TAK. So immediately I selected this round box here for the TAK, it comes up. So if you keep selecting all these listings, all the amino acids of the protein will start coming up one by one. But since I'm interested in only the ligand, and I know the code of the ligand, this is it here. I've selected it. I've selected that first round box, and that's why it's appearing. If I uncheck it again now, it will disappear. So if I select it, it will show again. And also, this box is here. You can see it's a box with sides of different colors: green, blue, red. One thing I need to do is to put this ligand inside this box. But also bear in mind that the ligand cannot move, but the box can move. So I have to adjust this box to cover the ligand. And in covering the ligand, it should not be so tight and it should not be so loose. It should not be so tight and it should not be so loose. So to move this box, I need this box. I need this table here. I need this red, green, blue. So if I want to, there are certain things I can do. These first three here, the first one, this place we are seeing 38, 40, 50, 40, 40. They are used to expand or contract the box. Then these colors down, red, green, blue, they are used to move the box. Depending on the direction you want to move the box. Let me start with the upper one, this expansion one. These ones are sizes. These ones are centers. This is size X dimension, 38 size Y dimension, size Z dimension, 40. So if I want to contract or expand the box in the red direction, see, I have red here and I have it opposite here also. So if I move this up or down, you see the box is enlarging or contracting in the red direction. If I do green, it's expanding or contracting in the green direction. You can see it. If I put my cursor on the blue and move it up and down, you see it's expanding or contracting in the blue direction. If I come here, I told you that these ones down, they are used to moving the box. If I want to move the box in the red direction, no more expanding now, to move the whole box in the red direction. See, I use this up or down. See, it's moving. You can take any side. It's moving the whole box now, unlike the other one that was expanding it. If I move this, if I move green, it's moving the whole box in the direction of the green color. If I move the blue, it's moving the whole box in the direction of the blue color. You can see it. So I need to make sure that this box covers this ligand. So because I have blue here by this side, so I need to move blue. If I move blue, you see, it's covering the box. Remember I said the box should not be so tight on the ligand and it should not be so loose. And it has to be in the center of the ligand should be in the center of the box. There's a cross arrow, plus arrow there in the center of the box. That tells us the center of the box. So I have to keep moving this box and keep contracting it. It's looking so bogus, so big on the ligand. So I need to reduce it. See, I can reduce the blue side. I have red up and down, so I can also reduce red. You can see as I'm reducing it, it's going out, it's leaving the ligand. So I need to expand. As I'm expanding, I need to be balancing. You see, I'm moving the red down now, so it's balancing. So if I need to also view the ligand from all colors. Now I'm viewing it from green, and it's one-sided. So what color do I have this side? Blue. So I need to balance it. This one is expanding. Can expand, then balance it. Remember I said not too tight, not too loose. Not too tight, not too loose. So this is okay. So I can go and view from the red. You see, if you view from red, you see that it's even outside. So I need to balance again. You can always move this so that you see what you are doing. So I need to move. So I have green here. So I need to move green. See, I need it to cover the box. As I'm doing this also, since blue is down, blue is also up this side. So I balance this. Remember, you need to be in the center. I have green up. So I can always balance. Then I can use this green also to shrink it a bit. Not too bogus, not too loose. So I can also view it from the blue side. If I view from the blue side, looking everything is okay, but see, like it's too tight somehow. So I can adjust the green, not too tight, not too loose. Looking somehow too tight, I can expand the red also. Then as I expand, I balance it. So once I've gotten something like this, okay, I can see that it's not too tight from all angles, not too loose. So I will take down these data because I'm going to use these data for molecular docking. These data will tell me where on the ligand is my active site. Where on the protein, sorry, is my active site. Where this ligand is bound to. So I'm going to take down these parameters as this first one, this first three, 1, 2, 3, is written as size X is 32, size Y is 48, size Z is 14. When I come to the center here, I'm not recording these offsets. I'm not recording these offsets here. I'm recording these ones. X, center X is 3.969. Center Y is minus 9.039. Center Z is 1.986. I'm recording these ones here, not these ones. So these are the parameters I use for my docking. Thank you. And then with the protein without ligand. So that's what I need for my docking. Thank you.